Okay, seems we're live. Last time, just tried this a couple seconds ago, and it tell me invalid path, but hopefully everything should be good now. Let's see. The Twitch mobile dashboard thing doesn't let me actually see my channel. Okay, here. Twitch mobile dashboard. Okay. See my channel. There we go. Perfect. Now I can go look at the dashboard. And here, got my chat up on the screen. Looks like we're ready to go. So happy Tuesday, everybody. Time to continue learning Rust. I noticed yesterday that I went to go press get push, but because this was a brand new system, I had not set up the keys yet, and I still need to do that. And so the code that I pushed yesterday hadn't actually made its way up, but now it is up there right now. So we are moving on to the Pig Latin challenge here, so the idea is that we're going to take this string, for example, hello world, and we're going to convert it into Elohe Earled Hey. And then we could add another word into here that has a vowel, let's say. So looks like what we first have is we're going to convert this to Pig Latin. Okay, so we're going to get the characters, so we're going to split everything into a vector and then collect them all in. Then we're just going to get the first letter and store that away into a string. Then we're going to create an empty string on the heap for us to sort of add things into as we're going on. Because right now we have an immutable copy, like a immutable borrow of the string, and we can't do anything with that. So we have to create a new one. So I believe that the easiest thing to do is just to, we could loop through and push everything into the string, or we can toString whatever is left from here. But of course we have a vector, so we would need to like somehow join it in. I think the easiest thing to do would be to loop through and put it into a string. So let's do that. So we'll do for letter in what is it? Chars. And what's interesting is that, well, we're not removing anything from, we're just grabbing the first letter. So maybe this wouldn't be necessarily the best thing. I probably want to do just like a number thing. So instead of like 0 or 1, I can do 2 ... and then I want chars length, but not only just -1, I want a -2. And that's because we saw at the end there was also a character there that, I mean, it looks blank, but it's a special character. So if we do this, now we should have access to, well, we should have, like, letter should be 0 and 1s, 2 through whatever the length of each word is. I'm going to call this the index. And what I want to do is say result.push, and it's going to be chars of I index. Expected character, found string. Oh, you know what? And so then I need to take this, whatever this is, and do to string. Or does it not? Oh, found string. So I need to char it. So I wonder if I can cast it. I wonder if I can say as char. No? Only U8 can be cast as char, not string. Okay, so it's because these are each strings. So this first letter is not what I think it is. And that's gonna be tough for me to like get out. So this split might not be the best idea for me to do, because getting them back into string will be potentially difficult. I wonder if I can just loop through each of these in an index, because I don't think I tried that. I wanna go through this. So I can word.split, because I can say for char for character in word.split. So instead of like collecting into a vector, this might be easier. Let's take a look. We're gonna print line the character. Just want to see what we got here. So we're gonna do cargo run. Expected one parameter. We have to split on a certain thing. So we're gonna split on every character. And so, yeah, it is giving us this. And we are getting, looks like we were getting those extra characters, but we don't have to worry too much about that. At least not right now. So I think the idea is that if we go through and we see like, hey, do we have a character? Then we can maybe pull things off and like put them into another word. The other thing is that if we convert this to an actual full string, the other choice is if I actually make this like a toString, like that. Now, of course, I can't pass. This is a standard string now, and I would be giving ownership to Pig Latin. So if I say string, expected string, founder's sanity. Okay. I guess I have to tell it. I have to give it like the full standard string. Oh, what was it? Standard string. Okay. String with lowercase, string with uppercase. Oh, I'm looking at the wrong function here. This is the function I'm doing here, which is this is string. That's the reason why it wasn't effective, like changing this to be better. Okay, so for Pig Latin, we split into words. And then for each word, we're going to send it on over to here. So now what are you? Expected struct standard string found. So okay, this is a slice, or basically a slice of a string. So we could create a new string and then send that on over. So we could say let w equals word dot, can I copy it? Or can I toString it? I don't know if I can toString this because it's not really mine to do. Okay, so that looks like it's copying out of the stack and into the heap for me. And it's not yelling at me, so unless it's just being delayed with that. Then we come here as an actual string, so I can do different things to the string. Let's sort of see what we have now that we own this string now too. So we're gonna have to return back to in order to like be able to get it back up here. Okay, so with this word here, we want to grab the first letter off, and can we index off of I guess standard string rust index character. Oh, I could slice something, I guess, because there is that slice idea. Because if I remember, I can do something like let first letter equals, it's going to be word. How is it? It's like word dot slice, or it's I forget the exact syntax of that. What are you saying? That's the num length, num string, num to string. Okay. I'm not. Oh, of course that's the problem. I think I want to go back into standard string. Can I get a string slice off of this? Okay, so if s is 0, I can get, oh, that's an error. Strings implement deref, so I'll inherit string methods. In addition, this means that you can pass a string to a function which takes a string slice. I mean, in the end, that's probably what I'm going to want to do. Okay, so can I grab from here? Oh, interesting. So there's the from raw parts. Can I get the raw parts? Okay, so from UTF-8, don't care about that. Don't care about the ones where I'm grabbing strings. I want to get things from the string. Okay, there's as string, as stir, ampersand self extracts a string slice containing the entire string. And what I want to do and then there's one into a mutable string slice. Appends, so appends a given string slice onto the end of the string. Can I get that first character though? I mean, I guess I can. Okay. Pop is removes the last character from the string buffer and returns it. Remove removes a char from this string at a byte position and returns it. Oh, this is an O of n operation as it requires copying every element in the buffer. Which, I mean, for this is not too bad because I'm not worried about that because I'm not working with huge data structures here. I'm curious about remove because that gives me a char. So index. So if I say that first equals word dot remove and I hand it like 1. And I print line the first letter. You are upset about that? Okay, so cannot borrow immutable argument word as mutable. Oh, so I need this to be mutable. You know what the best thing might be is to not actually like take full strings. So keep these as strs. Or maybe like for you, we could keep them as like a dot to string. So you stay there. We own you right now. We pass into Pig Latin sentence. This we just take a reference to a string. Expected stir found structured string. I was hoping I could pass in a just a reference to it, essentially like a borrow. Or can I do that right here? Yes, perfect. Okay, so then this one we're going to do the same thing. So we're going to make it so that you are string, and when we convert to Pig Latin, we're just going to pass in the word, right? So convert to Pig Latin, pass in word. Let's see what we get. Then we're fine. So we're back to not owning when we get into here, but we rather just have this reference to an area in memory where this word is. Now what we want to do is sort of remove here, but we can't, not right away. So I think what we want to do is take this and now convert our word to a string, which I believe just like copies and creates a new thing in memory for us. So if I say let word, so we're going to shadow this. So let word equals word dot to string. Now word is saying, oh, cannot borrow. So we want to make this mutable. Okay, so then if we take first letter is the first letter here, and then I want to like space and have the rest of this, the word should be like the rest of the word with that first letter removed, that's what we're hoping. So we end up removing the second letter because I was expecting the first letter to be that sort of like printed out blank space, empty character, but really like a special thing. So I should be able to actually get the real first character that I want. So H and W. So perfect. So I have this first letter now. And I want to then essentially put a dash on and then A with that. So we have our word, our mutable word, which is a full string. We own it, so we can do stuff to it. First letter, we remove this. I now want to try word.push. I don't think I can just do this on its own, right? Because I'm gonna have to convert that to, I have to, expected char found reference. Okay, so if I put, just to use this as a character, that works. I wonder if I can combine two like full strings. Because now I have first letter. I wonder if that's also here. If I do word.push first letter, okay, so first letter is also a character. So that's, oh, that's nice. It tells me that it's a character. Then, what was, AY is added. So then, of course, adding in this AY. So if I say AY, this won't work at all. But if I do toString, will it accept that? No, I can only do toString. I wonder if there's like a concatenate that I can use. Let's go find it. So off string, let's see if we can find like a concat. No. Oh, did plus? I'm trying to remember if plus is something that's allowed. So if I say like word equals word plus, I guess AY dot toString, just to make sure that it's also owned by me. Mismatch try. Oh, expected just this string, so this would have been fine. So I think that will work, and then we can now refactor this and combine it down into less lines and make it a little bit easier. But let's try to see if we have like a basic Pig Latin now. Elohe, Earled Hey. I can remove you. Now I do want to lowercase this letter. And so let's see if there's a char off of this. I believe, can I just do search? No. Search char. To lowercase returns an iterator that yields the lowercase equivalent of a char. Let's go to primitive type for char and go find that to lowercase. There's to ASCII lowercase. Is that what we want? Makes a copy of the value in its ASCII lowercase equivalent. To lowercase the value in place, but I can just return a new version of this. That's fine. So to ASCII lowercase. All right, let's try it. So it's just this first letter right here. So 2 ASCII lowercase like that, and hello, hey, Earled way. Okay, so that's perfect. Then of course now there is the problem with the first letter being a the first letter being a vowel, and then like something slightly different happens. I'm not going to worry about that right this second. I want to now like send this on back so we can do the print in the main function. Because once we have that, then we could just inside of here do a conditional to actually determine like what order we do things in. Okay, so we're printing the world right now. We now have the world. And if I remember correctly, what is the world? It's a standard string. So we want to give ownership. So we want to, I think I can just do return like this. So we return word plus we're going to return a string because we need to give ownership. Expected string. Oh, are you not returning? I have to do, will you return? Oh, wait, semicolon. That's the problem. Okay, so we return this new string. Now that comes back into here into Pig Latin, which is convert to Pig Latin word. And I think what I want to do is have like a result, and we push these in to here. So we can have let result equals, it's just going to be a standard string new. Now, what I can do is say result dot push and convert this to Pig Latin. Oh, I can only push characters, can't I? Oh, right. I want just pluses. So really what I want is this to be mutable. And I can say result equals result plus whatever comes out of this. Expected string, but founded full string. Oh, so I can't do it with that. So I need to, oh, that's interesting. Now, if I do this, don't I lose? It isn't, I'm gonna have a lifetime problem, aren't I? Let's try it. I want to make sure I get a lifetime problem. Well, okay, so that's just expected string, found the full. Okay, so I want let me word. So we have this as a toString. I have to do it as a toString. I wonder if I can then, yeah, if I now like put a reference to this, it's now going to be a complete different error. Implementation of stern ops add. Oh yeah, because I can't add these together. So like if I say word equals word plus a, and then I attempt to return a reference to word, now it's going to be saying, hey, it doesn't live long enough because we have a lifetime here. Like we have a problem where it's like, hey, we own this, but as soon as it's done, it cleans up the memory, so it's gone, so I can't give a reference to it because there's no point in memory. So it doesn't let us do that. So we do need to we do need to get rid of this and just return the full string and give ownership back to Pig Latin over here. So this will be a string. So what we can do is, as soon as we get this, we now need to make this an I. Just grab it like that. Yeah, so then we're to say like, well, we don't really care about what it is. We just want a reference to it. So we can add in the result here. Now, it looks to me like we're going to end up getting like maybe some kind of like lack of spaces between the words. That's my guess. So we're going to have to add that in, but then we'll have an extra space at the end that we'll want to like strip off of. So that might be interesting too. I'm wondering if it might be better to like throw these into a vector and then sort of join them together with spaces at the very end. That might be something to do. But okay, so at the end of this, we have the result. The result is a full string. So we now want to return the result, which means up here, we want to say that we're giving ownership back to main. Okay, so we call Pig Latin, we hand it the sentence, and now we want to say, let Pig Latin sentence equals this, and we're going to print the line. So I'm going to say this becomes this. So we'll say sentence, Pig Latin sentence. All right, let's give it a shot, see if it works. So hello world becomes hello world, world way. So hello hey, world way. So we notice that we do have this problem with spaces here. Now, one potential easy way to add this is like, as we're adding in these words, we can just add in an extra space. Now we'll have an extra space at the end. So if we care about that, we'll have to, at the very end of this, like remove the last character from it. Which we could do with that remove. I don't know if we want to. I did say that it was very expensive. But yeah, so this now works in a way we sort of expect it to. So I'm not going to worry too much about the fact that there's an extra space on here right this second. Instead, because I know I can remove it with this remove. Like I can just say like, hey, let's get the very last index of here, the length -1, and let's remove it. I mean, in fact, I could even do that because this returns a character, and result is already mutable. I could just say result.remove, and we're going to pass in result.length -1. That'll get rid of the space. We can't even tell. Let's see. Expected struct standard string found char was. Which one does it want it to be a char? Expected, oh wait, semicolon. Cannot borrow result as immutable because it also borrowed as mutable. Okay, so I need get a reference here. That's not a reference character. Cannot borrow result as immutable because it is borrowed as mutable. Immutable borrow curls here. Oh, okay. So if I like, because I'm doing some other tricksy things with that. So I wonder if I can get like let length equals result dot lang, like that. Which is now not used. And so theoretically, I can now say result dot remove length -1. Yeah, so I just couldn't do it all in one line. It makes me do this in 2 lines. This should still work. Of course, it can't tell because we couldn't see the space, like that extra space at the end, but now we know it's gone. So the sort of like last thing to add on to this is the vowels. The vowels, and then we can go through and like decide if we want to refactor this at all. So if the first letter is a vowel, so we have the first letter here. So it might be good for us to have like if is vowel, and then we pass in first letter. And of course, then we'll have an else and put everything else here. So if is a vowel, then we're going, what are we going to want to do? Well, if it's not a vowel, we know we want to just do word push. We want to just do this. And the other thing is, if is vowel first letter, I kind of get the idea that maybe we should just use match, because, oh, I didn't want to actually get rid of that stuff. Like, we only care about like one different thing. We can just match this and say match first letter. And if we match on non-exhaustive patterns, type char is non-empty. Okay, yeah, so we don't have all the arms in yet. So I want to say, if we have A or E or I or O or U. A-E-I-O-U. I think that's, yeah, I'm good with that. I know that sometimes Y, but I'm gonna ignore that for right now. So if these happen, then I want to, like, what do I want to have happen? And the other thing is like this could be the return right off of here. So we'll have like, and I'll ignore like what we do for this, or rather, what is this? Words that start with a vowel have hey added to the end instead of apple. So we remove, oh, so we just keep the A with apple. So that becomes interesting, because then we have a word with the first letter removed from it. So we have to put the first letter back on again. I kind of almost wonder if maybe like even doing this should be at the very beginning. So like we're just gonna match right off the bat essentially. Maybe except like this is right away. So if we do first letter, all we're really gonna do is we're gonna return the word plus A, like that. What are you yelling about now? Expected Standard string. Okay, so now if we have everything else is our underscore, and that's where all of this comes in. We say like, okay, well, we do yours, do all of you, and then we return that. Okay, first letter. Cannot find value of first letter in the scope. Okay, yeah. Well, that's because like we're getting first letter here, but we're removing it. So I don't want to remove it. I just want to see it, get it first. So can I say like I can shadow it here. So I can just say that first letter equals, can I just say word of position 0? Will that let me do that? The trait bound, standard string index integer is not satisfied. Okay, so I could either implement that trait, or, which I don't think we've gone through in the books yet, implementing traits. Let's see if we have. Because if we had, I'll just go look at how we do that and implement a trait with that new trait implement trait method that I got added into 1.2.6. Nope, chapter 10 is when we put in traits. So I'm gonna ignore that for right now, and let's see if we can get let's go back to string, standard string, and I want to get, let's see, so if I have just a slice from this, I can get the first thing. Oh no, I keep on thinking that this is fine, but they're giving me, like they're saying, that'll be an error. I wonder if there's like a get at index or get. Or if I can like get the iterator off of it. So creating a new string. Let's see if there's anything over here. There's this splice. Creates a splicing iterator that removes the specified range in the string and replaces it with the given string. The given string doesn't need to be the same length as the range. So like splice is removing. There was slice, wasn't there? There's get. Returns a subslice of string. This is the non-panicking alternative, returns none. 0 through 4. So I want to get like the first one. So like 0 through 1, I think. So dot get. Can I do that? And I can't remember if it's like, if it's 0, I think I can just do dot dot one, like that. Oh, found character. So that's giving me a slice of this. Can I then convert that to an as char? Non-primitive cast. Note an as expression can only be used to convert between primitive types. Consider using the from trait. So no, I cannot. So it might, I'm thinking maybe actually we put in this first letter here. We just go ahead and remove it, and we just put it back if necessary. And it is this big O of n, so it's not necessarily the best way to do it, but I can say like word plus hey, and then I can add in first letter. So first letter is a character, so I need to convert it to a string, and then I can add it on. So let's try this. First letter dot toString plus word plus a. Oh, and I need to add in, I need to make sure that I'm borrowing here. So no errors. So I think that might be working. Let's find out if we hand in like hello world, and then something like apple. So we get hello world apple, that becomes elo hey, erld hey, apple hey. So, okay, let's make sure that we got this correct. Convert strings to Pig Latin. The first consonant of each word is moved to the end of the word and a is added. So first becomes erst fe. Words that start with a vowel have hey added to the end instead. Apple becomes apple hey. Keep in mind the details about UTF encoding. Okay, so we have this working now. Like it's creating this Pig Latin according to these rules. And I can't remember if there's like other rules or other different methods. So let's take a look at ways we might want to decide to refactor this. So we're creating our sentence here, which, I mean, we're creating it as a full string, which allows us to retain ownership of it and then pass in the slices, or the stirs, which is, I think it's nice. And then we have Pig Latin sentence. So this is going to be the sentence we're getting back, and we're getting back this as ownership because this is going to be a full string. And then we just print that going. Now in here, we're calling the Pig Latin function and handing it the full sentence. And the sentence, we're taking in a slice. So a string slice, basically we're not taking ownership of it, so that when this function is ends, it's not going to destroy it in memory, which is fine. But we're also declaring we're going to create a full new string and give ownership back to the calling function, so that way when it ends, it doesn't get destroyed with memory. So in that case, this right here, we're creating an empty new string, or we're creating a mutable so that we can add onto it, because we're going to loop through. We're going to split through, which is an iterator, so it's going to create essentially like, it's not really an array, but it's basically going to say like, hey, get the word next, get the next word, get the next word, get the next word, split on this space. We're then going to be able to take this result and recreate it, reassign it to itself, plus then we have to have this this ampersand here, because this is a full string, and we can't do this with strings. We have to do it with borrows, or the string slices. And then of course, for good measure, we add on a space at the end. So the words each have a space between them. Now this is the convert to Pig Latin function. So if we jump down to here, convert to Pig Latin takes a word, but it's really another slice of a string. So we had created a full string up here. We're just handing it a reference to where it is in memory, or where it begins with memory and how large it is, how long it is. But we're going to, again, return a full string that's owned back here. So we create this string. We then remove the first letter from it. So remove is our most expensive thing here. And it's really expensive. And I mean, I guess we're doing remove here as well. But remove is expensive because it's a big O event. It has to loop through everything. And once it removes it, it also has to shuffle everything down. So no matter what I do, if I remove from the end or the beginning, it's got to move through everything. Now, luckily, we're working with short sentences, so it's not that actually big of a deal. It's nice to be able to have this. We can use it. And yeah, that's pretty much like, sometimes these are not bad idea to use if you have the processing power and you're not like working with some huge array or string in this case. Okay, so we get our first letter. It's a character now, and then we use match on it. So if it's an if it's an eval, if it matches one of these characters, then we're going to execute this block. And because we're not using a semicolon with this, it's just going to return whatever this returns, which is, the first letter, which we then also like toString this because, well, the first letter is a character. And then we add onto it a reference to the word itself and hey. Now that's because we remove the first letter, but we need to put the letter back on if it's a vowel. So the problem, like one way to make this better is not do this expensive remove if we have a if we end up having a what is it? If we end up having some kind of first vowel, we don't want to do that. Now I'm curious because I forget, like, can I do get? Can I say like that first letter equals word dot get at position 0? The trait bound, so slice indices are of type usize, or ranges of usize. Returns a subslice of string. Okay, so slice indices are of type usize or ranges of. That's really hard to read because it like goes off the side. Oh wait, now it's better, right? Now in some ways it's worse, in some ways it's better. Slice indices are type this. The trait standard slice index string is not implemented for integer. So, oh, can I? This has to. I'm passing in a integer, but it doesn't like that. It wants usize. But isn't usize just sort of like auto determining what it is? Or ranges. Oh, that's the problem. It wants a range. So if I do something like ... 1, that's what the problem. So if I do that, now mismatch type, expected enum, standard option found char. So first letter is now a standard option. If I unwrap this, will I get a character out of it? Expected string found char. as string or as char. Only U8 can be cast as char, not string. Okay, so the problem with doing it with this get, it's not like a huge problem. It's definitely like not going to be the worst things to do. I wonder if I can just do these as strings like this. Yeah, I think that's the answer, is to take these and turn them into double quotes like that. Whoa, why did you create double quotes? Okay. So that allows us, like, so we had to do the unwrap here because we got this option enum. I realize I'm running out of time, so I'm gonna finish this up really quickly. We have this first letter. Now we don't need a toString it anymore because first letter is now a stir. If I take a good look, it's a string slice. It's a reference to a string. So I can say first letter, and I believe that cannot be applied to standard option. Oh, right, because I have to unwrap this again. It might be easier just to then say let first letter, so to shadow this, equals first letter dot unwrap, like that. Now, of course, there'll be an error and it'll crash to the desktop if when it unwraps there is nothing in there and we get a none type. And in here, a binary operation cannot be applied to type string here. We have to give it a full string, I believe. So we can say .toString. Now the rest of them need to be string slices, just that first one from what I can understand, because this one has to be a reference, whereas this one cannot be. Okay, so that's just a nice way for us, like, okay, no, only do that, remove that first, like the second time, if we really need to. Now up here, we want to get the first letter. We want to now essentially move this down. And say, okay, well, we're going to shadow first letter again, and this time we're going to fully remove the word. Cannot borrow word as mutable because it's also borrowed as immutable. Where? It's immutable right there. Cannot borrow word as mutable because it is also borrowed as immutable. So on 23, oh, so it was borrowed as mutable here. Which then it's saying, like, well, hey, if you change it, then things can get really, really weird. So I wonder if I can, I can't remove it anymore. I wonder if I can, like, copy it. And it might be easier to, like, create two words from this, to, like, grab the first letter, because I still have that right here, and then get the rest of the word. So we say, okay, word dot push, but I really want, like, maybe another, maybe I want, like, result. So I'm gonna say, like, let result equals standard string new. So we start off with a brand new string, and I'm gonna have to go before I end up finishing this. But the idea is that we're gonna get this, we're going to then put on and get a slice, sort of similar to how we do get here, with just the first letter or the first character. We're going to get starting with the second character all the way to the end. And then we're going to, like, push everything in and then return that. So I don't know if I'm going to do that off stream or if I'm going to do that tomorrow morning, but that's sort of another thing to do. I will add this in here. So almost finished. Refactoring. And let's send that on up. Yes, don't show again. I think that's going to ask me, well, it might not ask me for my username and password. But with that, I am done for today's stream. This has been pretty productive, getting through and getting the Pig Latin. I think we have one more challenge to do before we can move on to chapter 9, which will be super fun because always moving onwards is great fun. I don't have the book open right now, so I have the learning Rust here. I'm going to add this into the comments in case you're watching the. Oh, lovely! It's not loading my chat at all. I hope nobody's been chatting and like I've not been able to see it at all. Which is not. Let's try it here. Nope, my chat is just completely broken. So sorry if you've been trying to chat with me. Apparently it's not showing up on my end or the screen. However, I do have my YouTube, a link to YouTube down in the description for the channel. That's where I'm going to be archiving this video and all the other videos in this series. I also have Twitter linked in there, and I believe, don't I have GitHub? If I don't, I'll make sure to add it in. Anyways, I do these streams every single weekday morning at 7 a.m. Mountain Time. And so I'll figure this chat thing out and hopefully fix that before tomorrow morning. So with that, I hope that you have a great day, and I'll see you tomorrow.